Good day, colleagues. Good day, grade 11 learners. My name is Mohapi. I'm working as the mathematics subject advisor here in Motao District. And the main objective for today is to discuss the examination preparation for Mathematics Paper 1, grade 11. Mathematics Paper 1, exam prep, grade 11. If just to cut long story short, the key behind this presentation today is to ensure that I bring learners and teachers on board on how the paper should be set. Remember, this year, because of COVID, we have had so many challenges. So we could not complete the curriculum for the whole year as expected. As a result, the curriculum was trimmed. So I just want to highlight to teachers as they set the examinations. I just want to highlight to learners as they prepare for the examination or prepare them on what to set and what to look for in the examination. Thank you. Without any use of time, my presentation is guided by the National Curriculum Statement, which we here in the Free State Province, we adjusted, but according to the instructions from the National. As you can see in mathematics, the implementation date is this November, December 2020. Let's carry on and see how the exam this year is going to come out. Thank you. Just a reminder to the teachers and to learners. Let's make sure that all the 5 SBA tasks are administered before learners sit for the end of the year exam. 5 SBA tasks, namely the investigation, and 4 tests. 1 test in term 1, 1 test in term 2, 1 test in term 3, and 1 test in term 4. So in each term, there is a test. Remember, over and above that, in term 1, you had an investigation. So all in all, it's 5 formal tasks. And all those formal tasks, each weighs 20% of an SBA. So all the 5 of them, 20%, they make 100. Like I'm indicating, the national examination, it will not be exam, it will be school-based. Exam will be school-based. Paper 1 will be written out of 75 marks, and paper 2 will be written out of 75 marks. So the total for both paper 1 and paper 2 will then result to be equals to 150 marks. This is so because of the challenges that schools experience, that the Department of Education has experienced due to COVID-19. I hope it's clear. Under normal circumstances, paper 1 will be 150, paper 2 will be 150. But because of the uniqueness of this year, paper 1 is 75 and paper 2 is 75. Both added together, they make 150 marks. Fine. Take note of the following. Examination will be set at school level. Teachers at specific schools are responsible for setting the end of the year examination. The date, because it is school-based, the date for the exam will also be determined by each school. It will differ from one school to another. So we don't have a common date, we don't have the common exam. Exam will be set at school, and the school, when they draw up the examination timetable, they will indicate the date for mathematics. But this is how the mathematics paper should look like. Paper 1 should be 75 marks, and the duration should be 90 minutes. Paper 2 should also be 75 marks, and the duration is also 90 minutes, 1 hour 30 minutes. Take note, integration of topics and concepts will be done when setting tests and examination. Teachers are encouraged to integrate topics because that is the trend in mathematics at the moment. That is the direction that mathematicians have taken to show how all these topics in mathematics integrate. Knowledge of content learned in the previous grades will be required and used when answering assessment tasks. When you set that test, some of the concepts will be from grade 10, grade 9. But because it is for grade 11, learners are expected to know those concepts. Remember, in paper 1, we have 6 topics. Out of the 6 topics, number patterns and financial mathematics will not be examined. So it means out of the 6 topics, Two falls out, namely number patterns and financial mathematics. The only topics that we are going to use for setting the examination teachers, those topics are algebra, functions. By functions, remember, we will also be referring to, we've got different types of functions: quadratic, hyperbola, exponential, and so on. Those are the topics that we are going to use for setting the examination. Let's check. Examination. Equations and inequalities. This is the estimated mark. We expect that equations and inequalities should carry about 11 marks. Which concepts should learners know? Solving the equations, the quadratic equation, remember, factorize, common factor, any method. Solve equations. You can solve equations by using quadratic formula. Sometimes you can complete the square to solve a quadratic equation. Under equations, product, simplification of algebraic expression. Simplification of algebraic expressions. Remember, like terms you can add them together, unlike terms you cannot add nor subtract. Factorization, talk of a common factor, trinomial, difference between two squares, difference between two cubes, sum of cubes, grouping. Those are different types of equations that we may come across, and each equation may require a particular methodology. Can take out a common factor, can group, but as you revise, because this is the stuff that grade 11 learners learned in term 1, so they must be familiar with this. Basically, all these concepts, they started in grade 10. Quadratic equations involving fractions. Quadratic equations involving fractions. They should also be expected to be there in the question paper. Simultaneous equations. Remember, if I talk of simultaneous equations, we talk of solving x and y at the same time, solving two unknowns at the same time. So this is simultaneous equations. Completing the square. We also have to solve the quadratic inequalities. Quadratic inequalities. All these topics here, equations and inequalities, we say they carry about 11 marks. The next one, exponents. Familiarize ourselves with the exponential laws. Know the exponential equations. When the bases are the same, you equate the exponents and so forth. Sets, remember how to eliminate a set. You square both sides. And under exponents, you also take note of the nature of roots. Nature of roots can also be examined under functions, under parabola. So nature of roots is a very versatile topic. It can be examined under exponents or under equations and inequalities or even under functions. So, but this exponents, exponential laws, exponential equations, sets, and nature of roots, 15 marks. We have equations, solving equations in two unknowns in other cases, or maybe in algebra, application of algebra to solve real life problems. It's 8 marks. Let's prepare the examination. Teachers, we need to start setting the paper long in advance so that it can even involve the subject advisor for moderation to ensure that quality task is given to grade 11 learners. Functions. Remember, I indicated we've got 4 different types of functions. Take note, this is the linear function. Learners must be able to determine the equation of a straight line, must also be able to draw a straight line. Even all the characteristics of a straight line, x-intercept, y-intercept, increasing, decreasing, gradient, all the stuff, learners must know. Let's talk about parabola. Parabola can take two forms. F at x equals a squared plus bx plus c, or f at x equals to a into x plus p all squared plus q. So this, the third one, a into x minus x1, x minus x2. Normally, look at the last 2 equations. You see here, you see intercept and a point. Sometimes the parabola can be drawn, and then you as a learner, you'll be requested to determine the equation of that parabola. So if you are given the x-intercept, and a point, and you want to determine the equation of the parabola, then you will use the formula f at x equals to a into x minus x1, x minus x2. Remember, when using this formula, x1 and x2 represent the x-intercepts. x1 and x2 represent the x-intercepts. But if the turning point is known, then we use the formula y equals to a into x plus p all squared plus q, where the turning point will be minus p and q. The turning point will then be negative p and q. There are characteristics under this that we should, under functions that we should know. In all functions, know how to calculate intercepts with the x's. We have the x-intercept and the y-intercept. For y-intercept, remember, x is 0, and for x-intercept, y should be 0. Be able to determine in terms of the parabola, the axis of symmetry. And the axis of symmetry is x is equals to negative p if given in this form, if the equation appears in this form. But if the equation appears in ax squared plus bx plus c, then the axis of symmetry will be equals, x will be equals to minus b over 2a. Remember, the axis of symmetry is a line that bisects the graph. It cuts the graph into two equal parts. Domain, these are all the values of x for the graph, range, all the y values for the graph, the turning point. Remember the quadratic functions, the quadratic function, which we call parabola, have a turning point. And you must be able to determine the coordinates of the turning point. And once you know the turning point, then it means you'll be able to determine the range, because you cannot be able to determine the range without the y value for the turning point. Very much important. We'll also, point of intersection, maybe a parabola and a straight line can be drawn on the same set of axes. So once the two graphs are drawn on the same set of axes, as a learner, you will be expected to determine the point of intersection of the two graphs. And how do we determine the point of intersection? By equating the two functions. Equating the two graphs, then you will be able to determine the point of intersection of the two graphs. Take note again, when dealing with functions, when do we say a function is increasing? When do we say a function is decreasing? Increasing and decreasing intervals. Learners must be able to identify that. The examination, a standardized question paper, must address those aspects. Hence, I'm requesting both learners and teachers to watch the presentation and try by all means to adhere to it. Ensure that grade level learners are exposed to a standardized question paper, despite the challenges that we've had with COVID-19. Other characteristics of functions that one should always ask when teaching learners on function: when will the two functions, one will be greater than the other, or the other will be less than the other? F at x greater than g at x, or f at x less or equals to g at x, f at x minus g at x is equals to 0, and so forth and so forth. These are some of the characteristics that, as teachers, while presenting our lessons, we should integrate questions that talk about those characteristics. As we explain content to learners, as we present different methodologies to learners, it's important. Every time, these characteristics must always form part of the assessment. Once learners have understood those characteristics, then it becomes easy for learners to respond to questions. Even when they reach grade 12, their work becomes so easy. It's very much important every time to include these characteristics in all the functions. Let's talk about the exponential graph. Exponential graph, remember, y is equals to a multiplied by b exponent x plus p plus q. Know the effect of the parameters. Remember the x-intercept and y-intercept. Clear understanding of the asymptotes. Remember, we define an asymptote as a line approaching a curve and never intercepting that curve. That is an asymptote. So an exponential graph has got one horizontal asymptote. One horizontal asymptote defined by y equals to q, where q is the constant. As explained in grade 10, the role of q is determines the shifting of the graph. If q is positive, the graph will shift q units upwards. But if q is negative, then the graph will shift q units downwards. Like I said, all other characteristics mentioned in 4 above also be examined when we talk of the exponential. Here are those characteristics. Here are the characteristics. Exosymmetry, domain, blah, blah, blah. All these characteristics must always be performed part of the assessment. Check the hyperbola. The hyperbola has got 2 asymptotes, one horizontal asymptote and one vertical asymptote. One horizontal asymptote, one vertical asymptote. So clear understanding of the equation of the exosymmetry is important. Hyperbola has got 2 axes of symmetry. Y is equal to minus x plus c, y is equal to x plus c. Those are the 2 forms of axis of symmetry that the hyperbola has. Remember, to determine the value of the constant c, use the point of intersection of the asymptotes, because axis of symmetry of the hyperbola always passes through the point of intersection of the asymptotes. I said y is equal to x plus c if the function is increasing, or if the function has a positive gradient. Then we say y is equal to negative x plus c. We have negative x if the graph is decreasing, meaning the graph has got a negative gradient. It's a decreasing function. So very much important with regard to hyperbola are the axes of symmetry. Y is equal to plus or minus x plus c. Already you've got the gradient. The challenge will be to determine c, which is a constant. And we said to determine the value of c, use the point of intersection of the asymptotes to determine the value of c, and then you'll know the equation of the axis of symmetry. Thank you. This is just an example to say if f at x equals 1 over x plus 2 plus 3, x equals to negative 2 is a horizontal asymptote, y is equals to 3 is mixed up. X is equals to negative 2 is the vertical asymptote. This is a vertical asymptote. X is equals to negative 2 is the vertical asymptote, and y is equals to 3 is the horizontal asymptote. Sorry for that mistake. All other characteristics mentioned earlier in question 4 must still be examined. Remember the characteristics. I can take you back to those characteristics, increasing, decreasing, and so forth. Thank you. And remember, on hyperbola, we're expecting around 8 marks. On exponential, we're spending around 8 marks. But here, because we've talked the parabola and the straight line, the intersections, 17 marks. If 2 graphs are drawn on the same set of it, then we can have almost twice the previous marks. Intersection, 2 graphs are more or less on the same set of axes, can be 17 marks. But if it's only one function, isolated, 8, 8. I hope it's clear. If you happen to have, as a teacher, you prefer to set a question where the straight line and the hyperbola intersecting, then you will expect more questions on the interpretation. As a result, that question will take 17 marks. Should be plus or minus 17. If I say plus or minus 17, it means it can be 14 or it can be 20. Anything in between. Fine. Let's check the last question. The last aspect is probability. Probability. Remember the grade 10 probability, where you discussed the probability rule and many other rules in probability. Definition of probability and so forth. You'll deal that with in grade 10. Venn diagram. Remember, for examination purposes, learners can go up to 3 events. Up to 3 events can be grouped, and then we use Venn diagrams to solve any questions relating to probability of those events. The probability rule, probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And remember, if we talk about A and B, we talk of the intersection. So we have what we call mutually exclusive events. For mutually exclusive events, there is no intersection. Probability of A and B is 0. Hence, the rule becomes, for mutually exclusive events, probability of A or B is equal to probability of A plus probability of B, because the intersection is 0. Complementary events. The probability of not A is equal to 1 minus the probability of A. This is the rule that can be expressed in different forms. If we have two sets, it's A and B. It's probability of A plus probability of B is equal to 1. Two events taking place, event A and event B. Therefore, the probability of A plus the probability of B is equal to 1. If I don't want to talk about the probability of A, B, I will say not A. So because it's either, if it's not A, it means it's B. We can also be examined on exhaustive events. Know the rule that is applicable for us to say two events are exhaustive. Tree diagram. This is a grade 11 topic. Very much interesting. I know teachers presently at the moment you are rounding off probability, busy with the tree diagrams and contingency tables and so forth. So we're expecting 8 marks on probability, and these are the concepts that should be assessed. Tree diagram, calculate the probability, product rule, probability of A and B is equal to probability of A plus that is the product rule for independent events. If we have independent events, then we know the probability of A and B is equal to probability of A plus the probability, multiplied by the probability of B. I'm sorry for that. For independent events, probability of A and B is equal to the probability of A multiplied by the probability of B. Take note of the contingency table. Contingency table. Remember what is key? The totals for the columns and the totals of the rows, they must correspond. That is very much important. So contingency table, not really that difficult. If learners can be taught properly, I don't think they will encounter problems in contingency table, because it's quite an easy to understand concept. Sample space, the overall total, learners must know, because if you talk of the sample space, talk of all the total number of all elements in a set. Because you're talking about contingency table, you've got to complete the table horizontally and vertically. Then use tables to answer the probability questions. Contingency table, make sure that all the rows, horizontal and vertical, the columns, they must be completed. And then we use that completed table, which we call the contingency table, to answer all probability questions. Let me remind teachers that whenever they set the examination, they must bear in mind the Bloom's taxonomy, the cognitive levels for the standardized question paper. The cognitive level still remains 20% knowledge. Knowledge, just the recall of the basic concepts. Routine procedures can be 35, complex procedure is 30, and the problem solving is 15. So you need to work out the 20%, 35%, 30%, and 15% of 75 in order to set a standardized examination or test. This is basically what to expect in the end of the year grade 11 mathematics. Nonetheless, I've talked of lots and lots of concepts. Let me try and give you a picture of how the questions should be asked. Take note of check the following. under equations. Solve for x in each of the following. This is a quadratic equation. It's already factorized, it's easy to solve. The second one is a quadratic equation, but it's not written in the standard form. Correct to 2 decimal places. The moment you come across a way to correct to 2 decimal places, it means for you to solve the question, it's either you use the quadratic formula or you complete the square, because the equation will not have factors. Learners, I hope you are listening attentively. Give answer correct to 2 decimal places. It simply means that equation cannot be factorized. So for you to solve the equation, you need to use quadratic formula or complete the square. Here is the quadratic inequality, the next one, and 1.1.3. And 1.1.4, we've got equations that involve sets. What is special about equations involving sets is that every time you need to check the solution, whether both two x values that you shall have obtained will both satisfy the original equation. Simultaneous equations. Solve x and y simultaneously if x plus y equals to 2y and y squared minus xy plus 21 equals 0. So the easiest method, just make x the subject of the formula. From this linear function, x plus 4 equals to 2y, just make x the subject of the formula. And then you come and substitute that x value here in y squared in place of x. Instead of x, you'll write 2y minus 4. Here is a question on the nature of roots. Can describe the nature of roots. And sometimes it can be for which values of p will the equation have real root and so forth. Determine the values of p if this equation has a maximum of 3 and 1 over 2. Very much interesting, because that p, it has got a role in the isosymmetry, and that is the maximum value. Maximum is the highest value of y. So this is more or less questions that one should expect. Check the questions under exponents. Can simplify an exponential expression, can solve exponential equations. Here they are. Please, grade level learners, familiarize yourself with this. Teachers, let's ensure that we expose learners to the previous year's question papers. Let's give them copies of the previous year's question papers so that they should be aware of the standard that is expected of them. As much as we have had challenges with COVID, the work schedule has been trimmed, but we expect learners to be exposed to standardized question papers. So even you as a teacher, when you set the paper, ensure that this paper that you set, the standard must be in line with the standard of the previous national papers. 2019 learners wrote the national paper. 2018, 2016, we have enough previous papers that we can use to guide our learners. We have enough of the previous papers that we can use to set standardized tests and examinations. Remember, questions do not have to repeat, but you can come up with something similar. This was basically the algebra part. Remember, I indicated that number patterns will not be examined. Check functions. This is more or less questions that will be expected, that learners will be expected to answer under functions. This is the hyperbola. You can show that hyperbola can be written in that form, 1 over x minus 3 minus 2. Because it's a hyperbola, definitely asymptotes, x-intercept, y-intercept, be expected learners to calculate. Learners are expected to calculate x-intercept, y-intercept, and the asymptotes. Any question that involves hyperbola, one way or the other, asymptotes, intercept with the x's must be there. Check 5.5, sketch the graph. Is indicated in all the functions. Learners must be able to sketch a linear graph, exponential, hyperbola, even parabola. Learners are expected to know how to sketch those. So it's either the equation is given, then learners are expected to sketch the functions. Or sometimes a sketch can be provided, then the learner's task will be to determine the equation of those graphs. Very much important. Because this question in particular was related to hyperbola. That's how you say determine the equation of the axis of symmetry. Check 5.6. I said hyperbola has got two axes of symmetry. One with positive gradient, the other one with the negative gradient. So this one in question in particular wanted to determine the equation of the axis of symmetry of F having positive gradient, meaning it's y squares to x plus c. X plus c. How do you determine the value of c? Check the intersection of the asymptotes. X will be 3, y is equals to negative 2. X is equals to 3, y is equals to negative. That is the point of intersection of the asymptotes. So it means in the equation for the axis of symmetry, y is equals to x plus c, you substitute y by 2 and x by 3. Sorry, x by 3, y by negative 2. Then you'll be able to determine the value of c. As a result, you shall have then determined the equation of the axis of symmetry. Transformation can also be applied. Domain and range and so forth. This is just to expose grade 11 learners to the type of questions that we expect the teachers to set at the end of the year. Learners must work hard. Functions forms a very important part of the curriculum, FET curriculum. And even next year when in grade 12, there's still functions alone. It will be functions and inverses. The topic will be weighing 35 marks out of 150. It's a lot of marks. The foundation is basically should be laid in grade 10 and 11, because in grade 12, learners should only focus on the inverse functions. Let me carry on with functions, questions on functions, just to expose grade 11 learners to them. Check this question 6. The diagram below shows the graphs of f at x equals to minus x squared plus 2x plus 15 and g at x equals to minus 3x plus k. Graph f, which is parabola, casts the x-axis at negative 3 and 0 and 5 and 0. We have the x-intercept. X-intercept minus 3, x-intercept 5. And the turning point is at D. This D is the turning point. Graph G, which is a straight line, cuts x-axis at B. It passes through this point. And cuts y-axis at C. E is the point on G such that D is parallel to the y-axis. DE, this line, is parallel to the y-axis. So let's check the question. Show that K is 15. Remember K, you go to the equation of the line. This straight line passes through B. So you just take the coordinates of point B, substitute x by 5, substitute k by y by 0. Then you will be able to determine the value of k. The next question, because now we have a parabola, then coordinates of the turning point. Parabola is, the equation is given, minus x squared plus 2x plus 15. So turning point minus b over 2a. Or you can add the two x's, 5 plus negative 3 divided by 2. Whatever method you can use, but because the equation is given, turning point is there. And once you know the turning point, automatically, as we teach these learners, when the turning point is known, then it becomes easy for the teacher to immediately explain to learners the issues of range. Because to determine the range of the graph, we use the y value for the turning point. As we teach, as we assess informally, we need to expose learners to all those characteristics so that come the end of the year, when learners write the examinations, they do not come across too many problems. Is this graph of f increasing? Give the interval. You see, from negative infinity, look, you are increasing up until here at the turning point. So determine the values of x for which f is increasing. It will be for all values where x is less than 1. Because check the x minus 3, 5. You add the 2 and then divide by 2, you'll have x as 1, meaning the x value here is 1. So from negative infinity up to 1, that graph is increasing. The average gradient between A and D, you have point A, which is minus 3 and 0. D is a turning point. You know how to determine the average gradient. Y2 minus Y1 over X2 minus X1. I talked earlier of the integration of concepts. That formula, Y2 minus 1 over X2 minus X1, is the formula we use to determine the gradient, mainly when dealing with analytical geometry. But now we're talking functions. We are integrating the concepts. The length of DE and the transformation here explained, and so on and so on. This is more or less type of questions that grade 11 learners should be exposed to. Check the questions on the exponential graph. It's giving the exponent. Determine the value of P. Because you've got point A, Y is 54, X is 3. Just substitute Y by 54, substitute X by 3. Then you've got the 3 marks. You take the value of P. Easy to determine. Determine the range. Remember the asymptote. Remember the asymptote. Y must be greater than the asymptote. That is how the range of exponential graph will be obtained. The graph of G is obtained reflecting F about the x-axis. Remember, reflection over about the x-axis. X will remain the same, but Y will change the sign. And the reflection over about the y-axis, Y remains the same, X changes the sign. Thank you very much. This is more or less questions on functions. The last topic that I want you to show, remember this is financial mathematics, and I said financial maths due to COVID. This during dreaming, when the curriculum was streamed, financial mathematics was taken out. Nonetheless, we still have probability. This is more or less the type of question that learners should know, should be asked, should be examined on probability. For any two events, A and B, it is given that probability of A is 0.48 and the probability of B is 0.26. Determine the probability of A and B. Remember the rule for independent events. For independent events, probability of A and B is equal to probability of A multiplied by the probability of B. So you multiply 0.48 multiply 0.26, write down the answer. Determine the probability of A or B if A and B are mutually exclusive. If they are mutually exclusive, intersection is 0. Therefore, the probability of A or B is equal to probability of A plus probability of B. I also highlighted the issue of tree diagram, and I also talk of the 3 events. Event A, chips. Event B, nuts. Event C, dried fruits. Sorry. This is more or less, we should talk of the 3 events in Venn diagram. This is what we are referring to. And I've checked the X here. All the sets, they've got X. This 25 is only belonging to nuts. This 30 is only belonging to dried fruits, and this 41 is only belonging to chips. Check this 5. This 5 is only nuts and chips. Check 6. 6 here is only nuts and dried fruit, and so forth and so forth. If 29 learners prefer at least 2 types of sense, calculate the value of X and Y. Check X is the intersection, Y is outside. Determine the probability that a learner who does not eat nuts will either have another snack or not a snack while watching television. These are the questions related to probability. We just have to determine X and Y. Once you've got the value of X and Y, it becomes easy to answer any question relating to probability. Because this one determines the probability that a learner who does not eat nuts will either have another snack or snack while watching television. You just have to exclude nuts, take out nuts, then you put the probability. Here is another question that requires tree diagram. 9.3.1, draw a tree diagram. These are the concepts that I highlighted earlier. Teachers, let's make sure that when we set the examinations, we include all different aspects under each topic. Learners must be well prepared. They must write a standardized test. a standardized exam. So teachers are given the opportunity to set the test themselves. So make sure that the standard of the test must be in line with the national standard. And this brings me to the end of the presentation for today. If I were to remind you again, paper 1 will be set by teachers at school level. The date will be determined by the school. The total for paper 1 should be 75 marks. And I did indicate earlier the weighting of the topics. The weighting of the topics at the beginning. Go back and look at the presentation at the beginning. I did indicate that algebra, this concept, marks should be 11, marks should be so much, and so forth. Very much important, teachers. Let's try and adhere to the guidelines when we set the papers, because it's only fair for these learners to be exposed to standardized question papers. On that note, teachers, good luck with the setting of the examinations. Learners, good luck on your examinations for grade 11. Wish you all the best. Thank you for the presentation today, and I hope you'll enjoy, and those who watched will definitely benefit. I thank you.